Welcome to Bot Thoughts by AmTalkSoft. I'm Alex, and today we're talking about something you've probably already experienced without realizing it. The last time you called customer support, scheduled a doctor's appointment, or ordered food through a drive-thru, there's a good chance you were talking to an AI. Voice AI has gone from science fiction to everyday infrastructure in 2026, and most people can't tell the difference anymore. Sam, how did we get here so fast?
It happened in layers, Alex. Three separate technologies all hit their quality thresholds within about 18 months of each other. Text-to-speech crossed the uncanny valley, meaning AI-generated voices became indistinguishable from real human recordings. Speech recognition got so accurate it now outperforms professional human transcriptionists. And large language models got fast enough to generate responses in real time. When you stack those three things together, you get voice agents that can hold natural conversations. And suddenly, the economics of customer service, healthcare scheduling, sales calls, all of it changed overnight.
Let's break down those three pillars for people who are new to this. We wrote a whole beginner's guide on our blog, Blog 33. But give us the quick version. What are TTS, SDT, and NLU, and how do they fit together?
Think of a voice agent as a pipeline with three stages. Stage 1 is SDT, speech-to-text, that's the ears. A microphone captures audio and a model converts it into text. Whisper from OpenAI is the most popular open-source option. It supports 99 languages and runs on a laptop. Stage 2 is the brain. That's your large language model like GPT-4 or Claude or Llama. It reads the transcribed text, understands the intent, and generates a response. Stage 3 is TTS, text-to-speech. That's the mouth. It takes the LLM's text response and converts it into natural-sounding audio. ElevenLabs, OpenAI's TTS API, and open-source models like Kokoro all do this. Chain those three stages together and you have a voice agent that listens, thinks, and speaks.
Let's dig into the text-to-speech side, because that's where the most dramatic progress has happened. We did a deep comparison on the blog, Blog 34, comparing 8 different TTS systems. What's the landscape look like right now?
The landscape is fascinating. At the top end, ElevenLabs is the market leader. They're valued at $11 billion and their voice quality is exceptional. Emotion control, multilingual support, voice cloning, they do it all, but they're expensive. About $12 per million characters. OpenAI's TTS is a strong second. Their new GPT-4o Mini TTS model is the first to use an actual LLM for speech generation, which means it understands context and emotion in a way traditional TTS can't. But here's the twist that surprised everyone. An open-source model called Kokoro, with just 82 million parameters, reached #1 on the TTS Arena leaderboard, beating models 1,000 times its size. It runs in real time on a CPU. No GPU needed, and it's completely free. For most use cases, open-source TTS is now good enough.
What about the speech recognition side? We covered that in Blog 35. Whisper versus Deepgram versus Google. What should people actually be using?
It depends on your priority. If accuracy is king and latency doesn't matter, Whisper Large V3 is the best. It's free, open source, handles 99 languages, and is the most accurate model available. If you need real-time, low-latency transcription, Deepgram is the winner. They specialize in streaming audio and can return transcriptions in under 300 milliseconds. Google Cloud Speech is the enterprise option with the deepest integration into the Google ecosystem. And then there's a new category of local models. Whisper can run entirely on your hardware with no API calls. For privacy-sensitive applications like healthcare or legal, this is huge. No audio ever leaves your infrastructure.
So we have ears and a mouth. How does a voice agent actually work as a complete system? We wrote a tutorial in Blog 36 showing how to build 1 in 50 lines of Python. What did that look like?
The 50-line version is surprisingly capable. You capture audio from the microphone, send it to Whisper for transcription, pass the transcript to an LLM with a system prompt defining the agent's personality and knowledge, then pipe the LLM's response through a TTS model and play it back through the speakers. The whole loop takes about 1 to 2 seconds. You can add conversation memory so the agent remembers what was said earlier. You can add tool calling so the agent can look up information, book appointments, or transfer to a human. The core loop is simple. What makes it hard is making it fast, reliable, and natural sounding at scale.
And that's where architecture comes in. We did a deep dive in Blog 37 comparing 3 different approaches: pipeline, end-to-end, and managed platforms. This is where it gets really interesting.
The pipeline approach is what we just described. SDT, then LLM, then TTS, all chained together. It's the most flexible. You can swap any component. Want to try a different TTS model? Just change that module. But it has an inherent latency problem. Each stage adds time, and they run sequentially. The industry median for pipeline voice agents is 1.4 to 1.7 seconds of response time. That's 5 times slower than natural human conversation pace. End-to-end models are the alternative. OpenAI's GPT-4o can accept audio input and produce audio output directly. No transcription step, no TTS step. It processes speech as a native modality. Latency drops dramatically, but you lose flexibility. You can't swap components and you're locked into one provider. The third option is managed platforms like Retell, VAPI, and Bland. They handle the infrastructure and give you an API. You define the agent's behavior and they handle the rest. Great for getting started fast, but you pay a premium and have less control.
Let's talk about that latency problem, because I think this is the make or break factor for voice AI. Humans expect responses in about 300 milliseconds. Most voice agents respond in over a second. Why is closing that gap so hard?
Every millisecond is a battle. In a pipeline, you have 4 latency components. SDT processing takes 200 to 500 milliseconds. LLM inference takes 300 to 800 milliseconds. TTS generation takes 100 to 400 milliseconds. And network round trips add another 50 to 200 milliseconds. That adds up fast. The tricks to reduce it are streaming at every stage. Start sending TTS audio before the full LLM response is done. Begin SDT processing while the user is still speaking. Warm up the LLM with conversation context before the user finishes their sentence. Edge deployment helps too. Running models closer to the user cuts network latency. The best production systems get total response time under 800 milliseconds, but that requires serious engineering. Most teams settle for about 1.2 seconds and call it good enough.
And then there's the cost. We titled our blog post about this, the $1,500 per day problem. What does it actually cost to run voice AI in production?
The costs are eye-opening. A single concurrent voice call requires about 1 full GPU worth of compute when you add up SDT, LLM, and TTS. If you're running a customer service operation handling 100 concurrent calls, you need serious GPU infrastructure. At cloud pricing, that's roughly $1,500 per day for 100 concurrent calls using commercial APIs. Self-hosting with open-source models can cut that by 60 to 70%, but then you're managing GPU clusters, model deployments, and scaling infrastructure yourself. There's also compliance. If your voice agent handles healthcare data, you need HIPAA compliance. If you're recording calls, you need consent in all 50 states. Illinois has BIPA, the Biometric Information Privacy Act, which has resulted in hundreds of millions in settlements. Most teams don't think about compliance until they get a letter from a lawyer.
Let's wrap up with predictions. Where is voice AI headed in the next 12 to 18 months? What should developers be paying attention to?
3 big trends. First, real-time translation is about to become seamless. We're already seeing voice agents that can translate between languages in real time with natural prosody. Within a year, language barriers in voice conversations will be essentially eliminated. Second, emotion-aware voice agents. Models are getting better at detecting frustration, confusion, or excitement in the caller's voice and adapting their tone and pacing accordingly. This makes conversations feel dramatically more natural. Third, edge deployment. Running voice AI entirely on device, no cloud needed. Apple, Google, and Qualcomm are all shipping dedicated neural processing units in their latest chips. Within 2 years, Your phone will be able to run a full voice agent locally with zero latency and total privacy.
Incredible stuff. Let me hit the key takeaways. Voice AI runs on 3 pillars: SDT for ears, LLM for brain, TTS for mouth. Open source models like Kokoro and Whisper have crossed the quality threshold. You can build a voice agent in 50 lines of Python. The architecture choice between pipeline, end-to-end, and managed platforms depends on your latency, flexibility, and cost requirements. And production voice AI is fundamentally an infrastructure and compliance challenge. If you want to go deeper, check out our voice AI blog series, blogs 33 through 38 at AmticSoft, blogspot.com. Subscribe on YouTube, follow us on LinkedIn and X, and support the show at buymecoffee.com/AmticSoft. Next episode, we're diving into the fine-tuning versus RAG debate. Until then, keep building, keep learning, and keep thinking.